Hey guys, welcome back to my channel. Thank you very much for joining me. For this video, I'm going to be explaining variance and standard deviation, how to calculate this by hand. In the next video, I'll do one using the table of values. Alright, so the objective for today's class is finding variance of a set of data and finding standard deviation of a set of data. Alright, so when we think about variance, this is the average square deviation from the mean. And when I say average, it basically means the sum of all the square deviations. And the deviation is basically you first finding your mean, having your data value, subtracting them, and finding the square of that number. When you square that number, you then find the sum of all of those numbers that you squared, and then you divide it by n minus 1. We use n minus 1 because we are given a sample and not the entire population. If we are given the entire population, here for the denominator we will only have divided by n. And variance is another short form that is basically called var squared. And from the variance formula you can find standard deviation by finding the square root of all of this section right here. I'll get to that soon. So for standard deviation, this basically shows the spread of your data values from the mean when your data is normal, when it's considered to be symmetrical. Alright? So it tells you how far the data values are and how close they are. One thing I always tell my students to look for is the shape of the distribution, because the shape can tell you how spread out or how wide you expect your standard deviation to be. Alright, so let's show an example. So like for this graph here, you see that the center, which is the mean, would be like somewhere right here, right? And if you should draw an arrow from the center to the end of your bell curve, you will know how far it is based on how wide your arrows are. So basically, when you look at that, so you can say the closer your bell curve is to the mean, as in the more squished in it is the smaller your standard deviation is, and the more spread out your bell curve is, let's say that's our center, the more spread out your bell curve is, or the more flattened it is, the larger your standard deviation is. Alright, so from that we can say it has a large spread or a small spread, or we use a formula, and sigma here means standard deviation, or sometimes you'll see SD, or sometimes you'll see S, depending on where you get your formulas from. There's the square root of the sum of x minus x bar, which is your deviation, all squared, divided by n minus 1. Again, n minus 1, because we're using a sample and not the entire population. So the deviation here is important, as you know how far each data value is from the mean. And the square deviation, no, that's where the variance comes in. Alright, so let's move on to a question. Let's say we have some data values. Let's do some small ones so we can have less time to work. So let's say we have these data values representing scores. We have 3, 4, 5, and 6. As you can see, these numbers are pretty close to each other, so we expect the standard deviation to be a pretty small one because they're like a 1 difference apart. Alright, so first step is for us to find the mean. So mean is represented by x bar. So x bar is 3 plus 4 plus 5 plus 6 divided by 1, 2, 3, 4. So the total sum of the numbers divided by the total number of items. So 3 plus 4 is 7, 7 plus 11 is 18, divided by 4 is equal to 4.5. So we have a center of 4.5. Very soon, I'm going to be representing this on my bell curve, so I'll let you guys know what that is. So from here, I'm going to use my formula and put the formula here so you can remember it. Use my formula to work it by hand. So sum of x minus x bar, I just found my mean, which is x bar, and that's equal to 4.5. I know my data values and these are the x's. So the 6, the 5, the 4, the 3 are all my x's, alright? So let's go. So standard deviation is equal to the square root of the first x is 6, so it's going to be 6 minus 4.5 all squared plus 5 minus 4.5 all squared plus 4 minus 4.5 all squared plus 3 minus 4.5 all squared, and you divide that by n minus 1. N here the total number of items. Here we have 4 items. So n, let me put it up here. So n is equal to 4. 4 minus 1 is 3. We're going to divide all of this by 3. So let's work it on a calculator. So 6 minus 4.5, and I'm going to square that. So right here, this gives me 2.25. So after I subtract it, I got 1.5, and then I square it, I have 2.25. So let's go for this one. And so you do this all the time, basically, to get the square deviation part of it. So that's a 0.25. And guys, I don't do questions in my head. From college days, my professor always tell me, don't trust your brain in an exam condition. And so I always know the answer, but to verify it, I always use a calculator. And that's okay. That doesn't mean you don't know what you're doing. Square 2.25. Alright. So I did my deviation squared and I got these for my answer. Now I'm going to divide this answer here by 3. So it's going to be 2.25 plus 0.25 plus 0.25 plus 2.25. And that gives us 5. So it's going to be 5 divided by 3 under the square root sign. So 5 divided by 3 is equal to 1.66. 7, let's round that off, and the square root of 1.667 is equal to 1.291. So I now have a mean of 4.5 and a standard deviation of 1.9. I can now represent my data on a bell curve, and for the bell curve, you know the center here represents your mean. So that's 4.5. If you're moving to your right of your bell curve, you're going to be adding your standard deviation consecutively. So you're going to be 4.5 plus 1.29. So right here, we're going to give me a 5.79. I'm going to add a 1.29 again. Keep adding 1.29 3 more times, because you know we observe 3 standard deviation above and below the mean. If you're not clear about this part, I'll explain this to you in another video. But for now, we're going to just be adding them and putting them there. So that's an 8.37. If you're moving to the left side of your bell curve, you basically be subtracting from the mean. So it's going to be minus 1.29 right here. So it's 4.5 minus 1.29. This negative 1 will give me 3.21. Let's go again, minus 1.29, so give me 1.92, minus 1.29 will give me 0.63. So this here represents 3 standard deviations above and below the mean. And very soon you'll be able to understand what percent of your data value lies between 1 standard deviation, 2 standard deviation, and 3. So thank you for joining. Remember to like, share, comment, and subscribe.